Download this code from codegive.com, link in the description below. OK, let's dive into the intricacies of implicit waits and page load timeouts in Selenium, exploring their relationship and how to use them effectively. We'll cover the concepts, differences, best practices, and code examples in various languages. Understanding the concepts. Implicit wait purpose tells the WebDriver to wait for a certain amount of time when trying to find an element, or elements, on the page if they are not immediately available. It's a global setting. How it works. When you set an implicit wait, the WebDriver will repeatedly attempt to find an element, or elements, defined by your locator strategy, example by.id, elementid, by.xpath, //div at class equals myclass, for the specified duration. If the element appears within that time, the WebDriver proceeds. If the time expires and the element is still not found, a nosuchelementexception is thrown. Scope once set, the implicit wait applies to all find element and find elements operations within the WebDriver instance. It persists until you explicitly change it. Ideal use case for applications with consistent and predictable element loading times. Useful when elements generally appear within a certain time frame, but sometimes take a little longer due to AJAX updates, animations, or other asynchronous processes. Important note: implicit waits can be a double-edged sword. Overly long implicit waits can slow down your test execution, even when elements are present immediately. Short implicit waits can cause failures if the elements aren't fully loaded. Page load timeout purpose sets the maximum amount of time the WebDriver will wait for an entire page to load. This includes downloading all resources like images, scripts, and style sheets. How it works. When you navigate to a new page using driver.get URL, or by clicking a link that initiates a page load, the WebDriver starts a timer. If the page and all its associated resources are loaded within the timeout period, the WebDriver continues. If the timeout expires before the page is fully loaded, a timeout exception is thrown. Scope this timeout applies specifically to the driver.get method and any navigation operations that trigger a full page load. It's configured separately from the implicit wait. Ideal use case for websites that might have slow loading pages due to network issues, large assets, or complex server-side rendering. It prevents tests from hanging indefinitely if a page load fails. Important note: the page load timeout is meant to handle catastrophic page load failures. It doesn't handle elements within a page that load asynchronously after the initial page load. 2. The relationship, how they interact, or don't. Implicit waits and page load timeouts operate independently. They address different aspects of the WebDriver's behavior. Implicit wait focuses on element availability within a page. It's about how long to wait when Selenium tries to find a specific element. Page load timeout focuses on the complete loading of an entire page. It's about how long to wait for the browser to finish downloading the HTML, CSS, JavaScript, images, etc., after a navigation event. They can coexist, but it's crucial to understand that an implicit wait will not prevent a page load timeout from occurring. Here's a breakdown. 1. Page load timeout expires first. If the page load timeout expires before a page is fully loaded, the timeout exception will be thrown, regardless of the implicit wait setting. The implicit wait is irrelevant because the page itself hasn't finished loading. No elements can even be searched for. 2. Implicit wait expires first. If the page has loaded, i.e., the page load timeout hasn't been reached, and you are trying to find an element using findElement, the implicit wait comes into play. If the element is not found within the implicit wait duration, a nosuchelementexception is thrown. 3. Both timeout *. It's possible, although less common, for both to time out. For example, if a page takes a very long time to start loading, the page load timeout could occur. Alternatively, if a page loads quickly, but a specific element never appears, due to a bug, for example, the implicit wait for that element might time out. 3. Code examples, Python. Let's illustrate these concepts with Python code using Selenium. Explanation of the Python code *. 1. Initialization *. We initialize the Chrome WebDriver. 2. Driver.set_page_load_timeout, 10, *. This sets the page load timeout to 10 seconds. If the page doesn't fully load within this time, a timeout exception is raised. 3. Driver.implicitly_wait, 5, *. This sets the implicit wait to 5 seconds. Whenever driver.find_element or driver.find_elements is called, the WebDriver will wait up to 5 seconds for the element, s, to become available before raising a nosuchelementexception. 4. Error handling *. The try, except block handles potential timeout exception, from page load timeout, and nosuchelementexception, from implicit wait. Proper error handling is essential in Selenium automation. 4. Code examples, Java. Here's the equivalent Java code. Key differences in Java *. System.set property, * You need to set the system property to tell the WebDriver where to find the browser driver executable. * Duration class * Selenium 4 and later prefer the java.time.duration class for specifying timeouts. * Thread.sleep, * In this example, thread.sleep is used to simulate a delay that occurs during Ajax update after page loaded. * Interrupted exception * In Java you must catch or declare checked exceptions, that is why you must catch interrupted exception. V. Explicit waits, the preferred approach for dynamic elements. While implicit waits and page load timeouts have their uses, explicit waits, using WebDriver wait and expected conditions, are generally the preferred approach for handling dynamic elements that appear after the initial page load. Explicit waits offer more control and precision. * WebDriver wait * A class in Selenium that allows you to wait for a specific condition to be true before proceeding. * Expected conditions * A set of predefined conditions that you can use with WebDriver wait, such as element to be clickable, visibility of element located, presence of element located, etc. Here's an example in Python demonstrating explicit waits. Explanation of explicit waits *. 1. WebDriver wait, driver, 10, * creates a WebDriver wait instance that waits for a maximum of 10 seconds. 2. ec.presence_of_element_located, by.id, my dynamic element, * This is an expected condition. It tells the WebDriver wait to repeatedly check if an element with the ID myDynamicElement is present on the page. The until method waits until this condition becomes true, or the timeout expires. 3. ec.element_to_be_clickable, by.id, my button, * This waits until the element with the ID my button is both present and clickable. 4. Precise control * explicit waits wait only for the exact condition you specify, rather than waiting a fixed amount of time for all elements. 6. Best practices and recommendations. * Minimize implicit waits * In general, avoid setting long implicit waits. They can slow down your test significantly and make it harder to diagnose issues. If you must use them sparingly and keep the duration short, example 2 to 3 seconds. Asterisk prefer explicit waits. Asterisk use explicit waits, WebDriver wait and expected conditions, for dynamic elements or scenarios where you need precise control over the waiting conditions. Asterisk set page load timeout. Asterisk always set a page load timeout to prevent tests from hanging indefinitely if a page fails to load. Choose a reasonable timeout value based on your application's typical page load times, example 10 to 30 seconds. Asterisk combine with implicit waits. Carefully, if you're using implicit waits, make sure the implicit wait duration is less than the explicit wait duration. Otherwise, the implicit wait might expire first and mask the explicit wait's purpose. Asterisk error handling. Asterisk always include try, except, or try, catch, blocks to handle potential timeout exception and nosuchelementexception exceptions. Log the exceptions and take appropriate action, example retry the operation, fail the test. Asterisk avoid sleep statements. Asterisk avoid using time.sleep, or thread.sleep, in Java, unless absolutely necessary. Sleep statements introduce unnecessary delays and make your tests less efficient. Use explicit waits instead. Asterisk smart implicit waits. Asterisk consider using smart implicit waits that only apply to specific element locators or within a specific context. This can be achieved by temporarily setting the implicit wait for a short period and then resetting it to the default after the operation is complete. This is not a standard feature of Selenium, but can be implemented using helper functions. Example of a smart implicit wait, Python. 7. Common pitfalls and troubleshooting. Asterisk implicit wait masking. Explicit wait. Asterisk ensure your implicit wait is shorter than any explicit waits. If the implicit wait is longer, it might time out first and prevent the explicit wait from working as intended. Asterisk incorrect locator strategies. Asterisk double check your element locators, example XPath, CSS selectors. Even with waits, if your locator is incorrect or changes dynamically, the element won't be found. Asterisk dynamic IDs or classes. Asterisk if elements have dynamically generated IDs or classes, you'll need to use more robust locator strategies, such as XPath expressions that rely on more stable attributes. Asterisk frames and windows. Asterisk if the element is within a frame or a separate browser window, you'll need to switch to that frame or window using driver.switch_to.frame, or driver.switch_to.window, before trying to find the element. By understanding the relationships between implicit waits, page load timeouts, and explicit waits, and by following best practices, you can write more robust, efficient, and maintainable Selenium tests. Remember to prioritize explicit waits for dynamic elements and use implicit waits and page load timeouts sparingly.